Good day, welcome to Memo's Tutorials. Today we are focusing on chemistry and we'll be looking at separation. So we have got three ways that we are going to talk about. Firstly being evaporation, followed by simple distillation and fractional distillation. So when we are looking at evaporation, our today's example, we have a salt solution. We just dissolved our salt in water. So this is now a solution. When we look at our solution, you cannot be able to identify the salt. You can't separate the salt from the water because it has dissolved. So on this experiment, we are having a Bunsen burner as our source of heat. We have our beaker there and a stand. So as we'll be applying heat to our beaker, water is going to evaporate. I hope you still remember that water can exist in three forms. It can be a solid, it can be a liquid, and also it can be a gas. So when you apply heat to a liquid water, it's going to evaporate in the form of gas, right? And that gas goes to the atmosphere. So at the end of the day, we are remaining with our crystallized salt. We are remaining with the salt at the bottom of our beaker, right? So at the end of the day, we have lost our water and we are only remaining with one substance, which is the salt. But when we look at simple distillation, it's a setup that is done in such a way that you don't lose anything at the end of the day. You remain with your salt in the RB flask, and then you receive your water there on the other conical flask. So you should be able to draw a simple distillation setup. You should be able to draw and label it correctly. Okay, so we simply have our burner as the source, a Bunsen burner as the source of heat there, and with our RB flask with a thermometer to monitor the temperatures. They mustn't be too high. Remember, we're dealing with glassware, and it's sold at the top. Take note of that when you're drawing the simple distillation setup. We have a condenser. Our RB flask, it's connected to our conical flask with a condenser, and our condenser has got cold air coming in, and then it has got an outlet where it goes out. So what happens is when you heat with the Bunsen burner, the water will evaporate like we are in evaporation there on the previous experiment, but then it's going to go to our condenser. Once it gets in your condenser here, it is cooled. The gaseous warm steam, it is cooled and it forms back to liquid, and when it gets back into a liquid, we're going to receive it in this conical flask on our far right there. Okay, so at the end of the day, we are going to remain with our crystallized salt in the RB flask, and we are going to receive water in the conical flask on our right there. So this is just simple distillation, and you should be able to tell advantages between evaporation and simple distillation. Okay, so now lastly we have the fractional distillation. There's the fractionating column that makes it different from the simple distillation setup, right? That's here, the fractionating column. I'm sure you can see it. It can be glass beads, round glass beads, as our fractionating column. So everything is exactly the same as the simple distillation, but that it's just that here we have got what you call the fractionating column, right? And so this fractional distillation, it's very, very important when we want to separate two mixable liquids. And a very good example of liquids that mix properly, that mix very well, it's alcohol and water. When you pour ethanol in water, you will not even notice. You can't see. But then when you want to separate these liquids, you separate them using fractional distillation because they have got different boiling points. So fractional distillation is a way that we use to separate mixable liquids with different boiling points. So as for ethanol, boils at 78 degrees and water boils at 100 degrees. So when your temperature has reached 78 degrees, all the ethanol is going to evaporate. It's going to evaporate, and we are going to receive it it's going to pass through the condenser, and we are going to receive it in this conical flask. So once your temperature reaches 78, it's going to stop there, and all the ethanol is going to move from our round bottom flask to our conical flask on the right there. So what will be happening here in the fractionating column, when we apply heat, remember, water will also, the steam will go up and the ethanol will also go up. So when they go up, when they reach the fractionating column, the gases are going to expand, and then they are going to come back to our RB flask, right, till the perfect temperatures have been met. When we reach 78 degrees, that's when the ethanol will then go all the way up and go through our condenser, converted back to a liquid, and then we'll receive it there, right? So that's how a fractional the fractionating column works. It will allow everything to evaporate to that fractionating column, but then when the temperatures have not been met, the exact temperatures have not been met, it's going to go back. It's going to back, the molecule will go back. If it's ethanol, it will go back till the temperatures reach 78. That's when it will be allowed to go and pass through the condenser. And the remaining gas, when we reach 100, we'll have collected all our ethanol, because ethanol boils at 78 degrees. So questions will come, they'll ask you the importance of the fractionating column, what's the use of the fractional distillation, and you may be asked to draw a simple setup of fractional distillation. You should be able to draw it, right? And that's all for today.